All right, hello, ladies and gentlemen. Time for a little lesson for this section 2-6 geometric proof thing. So what's going on is it's more just practice writing proofs, but now it's kind of transition with a few more definitions and things to work with. And so that's what's here on the front here. We're trying to just write some proofs, but now we're introducing some new kind of theorems. Some of them are things we've seen before, like reflexive property or symmetric property of things, transitive property distribution. You've seen those before. But some of these are a little bit different, like congruent complements theorem. If two angles are complementary to the same angle, then those two angles are congruent. Or we have things like right angle theorem. If two angles are right angles, then they're congruent. Some of these are like, well, duh kind of things. But they are reasons why we can say different things in proofs. And so, what we're going to do is just kind of use these on the front. There's a whole bunch of them. You have to like get familiar with what they are so you can write them in your proofs. So let's go to the next page here, and we're going to be justifying why some of these things are true and just kind of writing these theorems from the front. So first one, we got angle 1 and angle 2 added together makes angle ABC, which is this one here. And here's angle 1, here's angle 2, and it's like, yeah, those add up to be the big one. Well, there's actually a name for that, and it's the angle addition postulate, right? If you got two angles, you can combine them and makes the big angle. So we're going to write that down. The angle addition postulate. All right, the next one. If B is a midpoint of AD, then AB is congruent to BD. Well, you might have seen this before. If something is a midpoint, then it divides it into two congruent segments. And so on my justification here, I just write definition of midpoint. So the point of this whole page here is just like get used to kind of these postulates and definitions on the front, some theorems, and yeah, so that's what all that is. You just can find out what the names of things are. The next one, again, is just practicing this idea of writing proofs. We should write down things like givens. We should draw diagrams if we need to, state what's the given information is, and mark things. And so that's what this is talking about. It's just, what was the given information? What should we be marking? That kind of stuff. And then the latter part of this is you're given some things, you're supposed to prove a thing. It actually has all the statements here on the left, and you just have to provide the justification on the right. And I'm having you do this to like kind of get used to the process of proofs a little bit more, and some kind of novel kind of proofs we haven't done before. And so let's start with kind of a big one. Let's just jump to 18 and see if we can write down the justification for why these statements can be made here on the left. And so let's start at the beginning. N is a midpoint of MP. Here is MP. It's a midpoint. Well, we can know that because it's right here in our given. So we're right, given. Q is a midpoint of RP. Here's RP. Q is the midpoint. That's also in our givens, just right up there. Next one, Pn is congruent to Nm. Well, that's not one of my givens, so I'm not going to write given. But I can use the fact that we've established some things. We got some midpoints. Well, we got this one here. N is the midpoint of MP. If n is the midpoint, then that means either side of it is congruent. And so I can write that because of the definition of midpoint. Yes, I want you to write the words midpoint. Don't just write midpoint, but definition. The next one, PQ congruent to NM. So that's PQ and M. Those being congruent. Well, that's not a thing we can do because of midpoint, but luckily it's right here in our givens, so we're going to put that there. I know usually when I teach people to write proofs, I say start with the givens. This is kind of just like a rule of thumb. You don't always have to start with the givens, but you can, if you can make some other conclusions, you can sprinkle it in. But let's go to our next part. Pn congruent to PQ. Pn congruent to PQ. Well, we know that Pn is congruent to Nm, and PQ is also congruent to Nm. And so we're saying these two things are congruent. Well, that's a classic example of the transitive property. Both of these are congruent to Nm, and so they must be congruent to each other. And if you go back to the front there, it's also here, as soon as I find it, transitive property of equality. You just write transitive property and that'll be fine. So let's go back to our proof here. We've got a couple more lines. PQ congruent to QR. PQ congruent to QR. Yeah, well, we can just use the fact that we already know Q is the midpoint of RP. And so we can use definition of midpoint again. Oh, let me actually write this legibly. Definition of midpoint. And then we got our last line here, Pn congruent to QR. So it's QR. We got Pn. Well, that's going to come into play very similar to this one up here. We already know that PQ is congruent to QR. And we know Pn is congruent to PQ. And so we got this little connection here. Pn is congruent to PQ, PQ is congruent to QR, and so Pn has to be congruent to QR as well. And that's just another classic example of the transitive property. Yeah, so that's what's going on with this assignment. You're just getting used to kind of writing proofs some more using a few different definition things you haven't used before. So good luck.